Guys, welcome back. This is Bhavana. So today's subject is digital signal processing and the topic is about classification of signals. So when it comes to definition of signals, it is defined as a signal is a function that conveys information about a physical phenomena such as sound, light, temperature or pressure. Signals can be represented mathematically as a function of time or space. Characteristics of signals. There are five characteristics of signals, namely amplitude, frequency, phase, period, and duration. When it comes to amplitude, it is the magnitude of the signal. Frequency is the number of oscillations or cycles per second. Phase is defined as the angle between the signal and the reference signal. Period is defined as the time taken by the signals to complete one cycle. Duration is the length of time for which the signal is present. So, signals can be classified into several categories based on their characteristics, properties, applications. So, here are some common classifications of the signals. The first is continuous time signals, which is also known as CT signals. These signals are defined at all the points in time and can take on any value with the given range. CT signals are often represented mathematically using continuous functions such as sinusoids, exponentials, or polynomials. So the second is discrete time signals. In short, it is called as DT signals. A discrete time signal is a signal that is defined only at the specific points in time and can only take one specific values. DT signals are often represented mathematically using discrete time sequences. So the third is analog signals. Analog signals are continuous time signals that represent physical measurements or phenomena such as sound, light, temperature, or pressure. Analog signals are characterized by their continuous amplitude and time. So the fourth is digital signals. Digital signals are discrete time signals that represent information using finite number of distinct values or symbols. So digital signals are characterized by their discrete amplitude and time. So the fifth is periodic signal. A periodic signal is a signal that repeats itself at regular intervals. The signal has a fixed period and the waveform repeats itself after each period. The sixth is a periodic signal. These signals do not repeat themselves at regular intervals. So the seventh is deterministic signals. These signals can be precisely predicted. And the eighth is random signals. These are opposite to deterministic signals. So these signals cannot be precisely predicted. Ninth is energy signals. These signals have finite energy. So the 10th signal is power signals. These signals have finite power. Even signals, it is defined as these signals are symmetric about y-axis. Odd signals, these signals are anti-symmetric about the y-axis. Casual signals, these signals are zero for all negative time. So the 14th is non-casual signals. These signals are not zero for all negative time. 15th is linear signals. These signals obey the principle of superposition. And the 16th is non-linear signals. These signals do not obey the principle of superposition. So when it comes to application of signals, the first is communication systems. Signals are used to transmit information over communication channels. So the second is control systems. Signals are used to control physical systems such as temperature, pressure, or position. And the third application is audio and image processing. Signals are used to represent audio and images and are processed to produce high quality output. So the fourth application is medical imaging. Signals are used to represent medical images and are processed to produce high quality images. Thank you for watching.